Hello, this is Joe Neville and welcome to EVPN Config Snippets Part 2, an ongoing series where we look at the design and configuration of EVPN VXLAN networks. So the agenda today is that we are going to look at the configuration of a centralized layer 3 gateway, because this type of design does come up quite a bit. We're going to examine and look at the CLI, show commands and all those good things of what you would see on your layer 2 only VTEPs in this type of design, and we're going to do some Wiresharking. So a colleague of mine recently said that he liked it in the videos where you saw people doing packet captures and those good things. So we're going to take this to the next level, go deeper and fire up Wireshark to see what's really going on the wire. In the first video we looked at a design which utilized a layer 3 distributed gateway. Here it is. So what we have is we've got two servers here, both in the same subnet, both in VLAN 10. So server 1 here and server 2 over here. As you can see, the subnet is 10.99.10. It's a /24. We've got .16 here. We've got .17 over here. Now that VLAN is mapped to a VXLAN VNI of 10,010 so that we can traverse this layer 3 network to extend that VLAN 10 broadcast domain between clients. These clients think that they're on the same wire essentially, and if there was any inter-subnet traffic, each one of our VTEPs is configured as an Anycast gateway. With HPE's AOS CX, that's called an active gateway. And as you can see, so CX1 here, which is a 6300, that is configured within this subnet with the IP address of 10.99.10.1. So on the server, we would configure a default gateway pointing at .1 in that subnet, but also over on CX2 you can see the same. So we've got 10.99.10.1 there as well. So this is a virtual IP address and a virtual MAC address, so at layer 2, which is good for things like VM mobility, so you can move from one physical VTEP to another and still have the same default gateway address at layer 2 and layer 3. So in this case, CX1 and CX2 are both the layer 3 gateway for VLAN 10. Now that is a popular design, but there's another design which I've seen which is equally popular. I've seen quite a bit in the real world, and that is to use a centralized layer 3 gateway. So what do I mean by that? Well, here's a quick diagram of that. So what we have here is we've got our server. It's in the same subnet there, that 10.99.10/24. But rather than routing the layer 3 on the local gateways, what we do is we stretch the layer 2 outside of the fabric. So this is the VTEP that's terminating the VXLAN traffic there. And we have a layer 3 device that connects on the customer side outside of our VXLAN fabric, which will do the layer 3 routing for us. So we've got server 1 there, we've got a router which is not a VTEP, which sits outside. So this is a centralized gateway. And we extend that broadcast domain. So VLAN 10 there maps to VNI 10,010 as before, then it terminates. And again, that is as before in our simple example in the first video to VLAN 10, but now it's terminated on this layer 3 device, this router 1 that I've got here for inter-subnet traffic for routing off to a different subnet. In that case, server 1's default gateway will be configured with the IP address of router 1. Okay, so let's step through though. How do we get to that point from our initial design? Okay, so here's the initial design from video 1 of a distributed gateway, and let's transition this then to our new centralized gateway design. I'll do that visually in slides and then I'll jump on the config. So let's just really show you the different steps to build up the centralized gateway and what I'm going to do then. Okay, so what do we need to do to move this design to centralized gateway? Of course, first step is to take away that active gateway configuration on CX1 and CX2. So they just act as layer 2 bridging devices doing the switching. It just so happens that some of that bridging is onto a VXLAN network. Don't worry if that doesn't make too much sense. We will be looking at the config. Also, I'm going to take off server 2 from CX2 and replace that with our router 1. So router 1 is another HPE AOS CX 6300, so the same as CX1 and CX2, but in this case it's not a VTEP, okay, so it's just a layer 3 device running IP. And also, so I'm still using server 1, and that's still going to be in VLAN 10, and I'm still mapping VLAN 10 to VNI 10,010, and that VLAN, so that broadcast domain, that's going to be allowed on this trunk, so between 1/1/3, between CX2 and router 1, I'm going to run that, and that's the standard .1Q link there, so a trunk. Also, I'm going to add in a new VLAN, so VLAN 20, because we want to do some inter-subnet traffic, some routing on router 1 to prove that this works. So server 2, I've transitioned that to VLAN 20. You can see that is in a different subnet, so 1099.20/24 as .16. This is 1099.10.16 for server 1. So server 1, server 2 in different subnets, in different VLANs. And then that VLAN 20, I'm going to map that to 10,020 across between CX1 and CX2, and also extending that VLAN down to router 1 there on that trunk. So router 1 is the layer 3 gateway in this case. Any traffic that we want to route between 10.99.10/24 and 10.99.20/24, so going from server 1 to server 2, will go across our VXLAN network. It will be routed by router 1, and then it will head back on the destination VNI to the destination server. Okay, so in this case, CX1 and CX2, these are just layer 2 devices, so they will do switching on any of the .1Q ports that they've got locally. So anything local will be switched in that VLAN, but to get to the default gateway from server 1 off of server 2, it's going to do a layer 2 bridging. It just so happens, like I say, the bridging goes onto the VXLAN network, so it will be mapping between a VLAN and a VNI. And in this case, we're just using VXLAN L2 VNI. So we're just using that layer 2 functionality, because you can see here. So just to, be really unambiguous about this. So we've got this broadcast domain here, which is VLAN 10 to VNI 10,010. And you can see that here on the server 1, you can see that across the VXLAN fabric, and then you can see that down on this trunk to router 1. So .1Q there, and a VXLAN VNI. So that essentially the broadcast domain is stretched from here to here, and the tagging, so the way that we identify it, changes as it moves through different parts of the network. So you've got 802.1Q here, and you've got a VXLAN VNI in the middle here. And again, conversely, you've got the same thing for VLAN 20. You've got .1Q there, and VXLAN VNI in the middle between our VTEPs. Okay, so to put that all together, this is what we are going to build. The router 1 being the layer 3 gateway. And where else do we see this type of design? It's when we have a centralized firewall. So if we have some kind of firewall for security policy, a lot of times in networks today, it will still be a centralized firewall that is installed. And so between, say, in this case, we've got between subnets, it could be between VRFs, which I'll do in a later video, we would have a centralized point for the enforcement of our security policy. So we ship our traffic to a central point to apply that policy. I'm not going to be doing security here, but this essentially shows you the IP connectivity options for getting that traffic to the centralized point. Of course, it's not the most efficient, because as you can see, we've got server 1 and server 2. They're sat on the same switch, but they would need to traverse this core to be able to get between each other. So that's why a distributed approach can be more efficient for our traffic flows, but with so many things within networking, it's a trade-off, because it is very common to have a centralized firewall. And it'd be really remiss of me to present this and not mention the fantastic HPE Aruba Networking 10K device, which can provide you with that distributed firewall functionality. And we should say that from the point of view of the servers, they are unaware of the layer 3 and the VXLAN network that sits between them and their default gateway, because it's just L2. It's just switched from their point of view. Okay, so server 1 is configured with the default gateway. So I've hard configured the default gateway for its subnet. So 1099.10/24. I've given that on router 1, it's configured, I'll show you this, it's configured as an SVI for 1099.10.1 on router 1, and server 2 will have a default gateway which is 1099.20.1, which again is a layer 3 interface on router 1. And these devices, they will just ARP for their default gateway and then store that in their local ARP cache, which will be the IP address and the MAC address from router 1. Now, router 1 is using the same MAC address across the different VLANs. And our devices like CX1 and CX2, because they're just acting at layer 2, they will not have anything in their ARP cache. They do not participate at layer 3 within these subnets. That's something that I really wanted to cover in this video, to really drill that home about what to expect to see on the different devices. But we'll step through. I'll show you the ARP cache on the servers and on router 1, and I'll show you the various show commands on our VTEPs. Okay, so let's get on with the config then, and what I'll do, I will endeavour to maximise my screen real estate as much as possible. I will have my CLI login up the top here, and I will have a diagram on screen for you to follow on as much as I can. Okay, so let's jump onto our new device. So this is router 1. Now this is just an HPE Aruba Networking 6300, just like CX1 and 2, but it is just configured for IP. Haven't even got a routing protocol on here. It's just doing routing between directly connected interfaces. I will show you the config. There is not too much to get excited about. So I'll go down to, this is the layer 3 then. I told you that I would move the .1, so the default gateway IP addressing, that's been moved to router 1, transitioning from our distributed to our centralized. I've already done that part. So as you can see, we've got a layer 3 interface for VLAN 10 here, and it's 1099.10.1/24, and the same again for VLAN 20. That's it. There's no routing, like I said, no routing protocol required for this. Our servers are going to communicate with our default gateway, and the default gateway will do the routing, and we'll do a ping between the servers at the end. Okay, so if we look at the routing table, then you'll see in the routing table it's going to be connected interfaces that we are routing between. So these subnets, these 1099.10/24 and 20/24 there, we will be able to route between those on our device. Sometimes these are called routers on a stick. Okay, not many people say that nowadays, but there you go. Right, and what else should I show you then? Okay, so I have, so that port 113, so 1/1/3, that is a trunk, and we are allowing 82.1q tags of 10 and 20. That's our link there. There's no VXLAN, there's no BGP on this device. Okay, let's jump over to CX1 then. That's where it gets interesting. So this is where we're going to do the configuration part. Okay, so over on CX1 then, so our 6300 acting as a VTEP, what I've done is I've stripped off a lot of the config. So I've stripped off the EVPN, the BGP, and the VXLAN. We're pretty much just starting as an underlay device with our layer 3 connectivity and our OSPF. I will show you the config, so not too much going on. So this is this 1/1/2, so that's our OSPF point-to-point layer 3 link to connect to CX2. I've taken off a lot, I've got the loop back on there, and OSPF. So I should have my OSPF neighbor up, and I do. So that is CX2 that you can see here. That's the loop back. Right, let's get on with the config to build this up. I believe I do have the VLAN on here already. Oh, yeah, okay. We've got the VLAN already. Good stuff. So I've got 10 and 20 on this box. I don't have the layer 3 for the 10 or the 20. There's no active gateway. Just show you that, you see. I don't have any of that configuration. This is just going to be layer 2. Right, so where are we? Let's go with, where should we start? Let's go for some BGP then. We set up BGP like before, and our neighbor is going to be 2. I will do it in the same AS again. And our update source, of course, is going to be our loopback. Okay. And we need our L2 VPN, EVPN configuration. We put our neighbor in there to configure it and activate. And also, do not forget, send community both. Great. Now, what else do we need? We will go over to, well, I'll tell you what, let's come out of here, show BGP. Well, what would it be? All sum, I should see it. There we go. Right, already established. Fantastic. Let's just check as we go that I've configured this correctly. There we go. So we are up. Right, the next step. So I've done the BGP. Let's do the EVPN then, which is actually pretty simple for these examples that I'm doing. I'm going with the basics. In this case, we need VLAN 10. If I can press the right keys. And route distinguisher auto, route target both auto. Fantastic. And also I need VLAN 20. Of course, this is new for this device. I didn't do this in the last video. So VLAN 20 on here, and I'll just go route target both. Excellent. And so let's go for the interface VXLAN 1. Of course, source, will I remember? Yes, I have. 172.16.0.1. No shut, the other one that I always forget. So VNI 10,000 and 10. Map to VLAN 10. VNI 10,020. Map to VLAN 20. Okay. There's our EVPN. Wonderful stuff. Go down, we've got our BGP and we've got our VXLAN on there. Very much cookie cutter configuration that can be templated. Okay, and because I want to step through this methodically, what I'm going to do is I'm going to shut down the two interfaces that connect to my servers to start with, so that we can step through piece by piece, right? So with those down, and I don't have any configuration on them, if I do a show run interface, so it's 10, 11. So I've defaulted those. This is this port here. So 1/1/10, shut it down. It's just default at the moment, but I've shut it down. 10 and 11. Okay, so if we look at the MAC address table, there's nothing in there as well. We have, I've already shown you, haven't I? The BGP is configured and we're established. But what I've also got is on CX2, I've actually got that port shut down because I want to control what we see in the tables and build that up step by step. Personally, I think that's easier to follow. So if we look at our MAC address table for local learning, remember, we don't have anything in that MAC address table at the moment. I will configure these two ports, so 10/10, right, which one? Oh, come on, this one. Let's put that VLAN access 10 is correct, and 11 is 20. Good. Okay, I'll go back to port 10. Then, like, hitting the wrong thing. Right, trying to do this as close to live as possible. Don't get me anywhere near a production network nowadays. I keep typing in the wrong thing. Okay, so no shut, that one. And do we see anything? Let's have a look. Okay, we do. Right, so what have we got? We've got locally learnt. We've got the MAC address table. And you can see that I've recorded it here. So it's this MAC address 1BDE94. There we are. And that is learned on VLAN 10 dynamically because it's local learning on port 1. And if we go into 11, no shut, and we come out of there and we go show MAC address table Will we see anything pop in? Ah, we have. Okay, so our device has heard from server 2, and for the eagle-eyed you'll see that I've changed server 2. I've introduced a different server into my network between video 1 and 2. It's a different MAC address there. Nothing sinister going on. I just felt like installing a newer piece of kit. They're both Linux servers, both of these, both Ubuntu. Okay, so you can see the MAC addresses there, VLAN 10, VLAN 20, locally learnt. Now, let's step through then using the method that I showed in the first video, and if you've not watched that, the approach that I've taken is that I look at the MAC address table and then I look at the show EVPN MAC and IP table. There we see. So EVI, so it's the EVPN instance of 10,010, and remember that comes from on AOS CX. That's not configurable. That just comes from the VNI. So 10,010. That's going to be VLAN 10. You can see that MAC address there for server 1, and that has the flag against it of L because it's locally learned. And then EVI 10,020, you can see this F4 MAC address, which is server 2. So we've got 2 locally learned MACs, no remotely learned MACs at the moment. If we look into our BGP table, so our L2 EVPN table, what do we expect? Okay, of course, we've got our root type 3s, our IMET updates there. These are the locally injected ones from .1, and you can see our MAC address. So we've got a root type 2, and notice it is a MAC only root type 2, so you can see root type 2 there, injected locally. This is the next hop is the local device, but you can see that it doesn't have an E or an I against it. It's been locally injected, and there's the MAC address. We can also see, so the next entry here, we can see, so that's the loopback, so the root distinguisher, sorry, I've used the RD Auto, so the loopback for CX2 is 0.2 there. For VLAN 10, we've just got the root type 3 with the next hop of 0.2, because there's no root type 2s for that from CX2. CX2 is not advertising any root type 2s at the moment. It hasn't got any MAC addresses. It doesn't know any MAC addresses in VLAN 10 or 20 to create the root type 2s yet. So we've just got our locally injected ones. There is for VLAN 20, so that F4 MAC address being locally injected and nothing from CX2. Okay, that's the MAC table, the EVPN table, and the BGP table. If we jump over to CX2, let's go out of here, go over to CX2, show you the configuration. There is my EVPN, of course, very, like I said, cookie cutter, very similar. I've not turned on any of the optimizations or any of the flags like art suppression or anything. I'm just going for the basic at the moment for this basic connectivity. What else have we got? The VXLAN, of course, I've already configured that on there. We've got our OSPF and we've got our BGP. It's essentially the reverse of what we put onto CX1. And let's step through then. So if we go BGP, L2, EVPN, we will be able to see the MAC addresses that have been learned from CX1. So for example, we have from iBGP, we've got a valid and best root type 2 for the MAC address, which is server 1. That's server 1 there with a next hop of 172.16.0.1. Fantastic stuff. We haven't got anything, so this would be where we see the local entries injected with this root distinguisher for VLAN 10, and then again for VLAN 20, but learnt from CX1 with this root distinguisher here, so the loopback from CX1 and the VLAN number creating the auto root distinguisher. There we can see we've got the MAC address for server 2. Again, root type 2, we're not injecting anything. Okay, we also can then go to, of course, the EVPN MAC and IP table, and we've got those with the next hop that's learned remotely. This is the destination IP address for the VXLAN encapsulated traffic, and there we have the remote flag. You can see two remote MACs listed against our EVPN table. And then finally, the ever reliable show MAC address table. We can see we've got a couple of entries of interest here, which have come from the EVPN table. You can see the type EVPN VLAN 10, that's server 1, and that is server 2, both known via the VXLAN network being advertised by CX1. So that's fine up until this point, but we don't have our default gateway yet. So let us open that interface. I think if I just, here we go, you can see that it's a trunk. I'm allowing those two VLANs across that trunk. It's currently shut down. I will go in and no shut that. Now, if we go, so these will be locally learnt. So I will go through the tables like this. Will we hit? Okay, we have. Excellent. So we have heard from router 1, our layer 3 gateway. This is the MAC address. I think I've got it correctly, haven't I? 053840. Yes, I have. So on VLAN 10, like I said, it's the same MAC address on both VLANs. Dynamically learned, so it's locally learned on that port 1/1/3. Because we have those two VLANs configured for EVPN, you will see that in the local EVPN table as locally learnt. There you see two locally learnt MAC addresses on the different VNIs. It's the same MAC address, and then we can go to the BGP table. Ooh, come on, EVPN. And so now CX2 is injecting, so this will be to the route distinguisher VLAN 10. You can see the RT2 for our default gateway. Notice there's no IP address. We're not participating at the level of CX2 with IP. We're not doing layer 3 in this network, okay? So it's just layer 2 that's happening there. So you can see a route type 2, just a MAC only route type 2. And again on VLAN 20 with this route distinguisher here, you can see the route type 2 for router 1 being locally injected. We'll come out of here, jump back to CX1, go through the tables, BGP, EVPN. Okay, there is the route type 2 learnt from CX1 for VLAN 10 and for VLAN 20. EVPN MAC IP. Now on CX1 we do have two remotely learnt MAC addresses. Same MAC address, different EVIs, so different EVPN instances in this case. And then finally we will see those both in the address table. So same MAC address, different VLAN. It's listed learnt via EVPN with CX2 as the next hop. Okay, so if we look at, I'll look at my ARP cache on CX1 to show you what's there. Not much. Okay, so CX1, CX2, they are, jump over to CX2, they are, show ARP. They don't ARP for this default gateway. They just perform at layer 2. So you can see it there. Scroll down here. You can see it. So ARP cache there. We don't have the layer 3 gateway in our ARP cache. We don't actually have an IP address in that subnet on CX1, CX2. In a centralized gateway, this is how these VTEPs will operate. They will just operate at layer 2. Okay, but do we have connectivity? That is a good question. So let me I'll jump onto server 1. There we are on server 1. And I will try to ping the default gateway, which is 10.99.10.1. Can I ping it? I can ping it. So this is server 1 pinging from over on the left here via CX1 over to CX2 because it is looking for the default gateway. Now what's happened in the background there is that server 1 has ARPed for the default gateway's IP address and MAC address. Let's check server 1's ARP cache and you should see, yeah, here listed as gateway. you've got 10.99.10.1 and that's the MAC address of router 1. That is listed on server 1. So the ARP request and reply, it happened between server 1 and router 1. Looking at CX1, do show up, nothing there. Okay, to really drill that home, you can see there's nothing. I know that's crashing a little bit there, but you can see there isn't anything on our devices because that layer 3 resolution is happening on our server. So we can ping our default gateway, that looks good. Of course, where do we want to ping next? Let's ping to our neighbor. So let's go from server 1 to server 2. So pinging to 20.16, which will be via the default gateway. Does that work? Yeah, it does work. Okay, fantastic. So I can ping from server 1 over to server 2. It's not going directly through, even though both of them are connected to CX1, it's going via router 1, this as the L3 gateway here. And I should say, on the server side of things, on Ubuntu, I've used NetPlan to actually add a route in via the default gateway. So if you do a route on these devices, let's do a route, I think -n, yeah, okay. So I've got a default gateway, that's my management side of things. This is my management network. But what I've also done, so I can log into this via my management network and do our configuration here, I've added in a specific route. So this is server 1, which is on 10.99.10. That's locally connected. I've used NetPlan. Okay, don't judge me. I've used NetPlan to configure a route to 10.99.20/24 via 10.99.10.1. Okay, so via the default gateway. I've done the reverse on server 2. Okay, so what we can do is we can get from server 1, we can go across our 802.1q network, hit our L2 VTEP, send our traffic right across our VXLAN network to CX2, then across our 802.1q trunk to router 1, which is our default gateway. We route that and then send it back across the link to server 2. From the point of view of server 1, it's just doing an ARP broadcast out, looking for the MAC address of the default gateway. So that's the ARP request. It's got the IP address of the default gateway. It needs the MAC address. And from the point of view of the VTEPs, what they are actually doing is that they are using their tables for the connectivity for the route, which they've learned from EVPN with route type 2s propagating that MAC address. They're working at the layer 2 level. They're working at the MAC address layer. And I really want to emphasize like the different roles that the devices are playing here, because that really helps you to kind of really understand this, I think. So server 1, that has a default gateway of 10.99.10.1. So it will send, when it first boots up, it will send an ARP request for that IP address looking for the MAC address. This will be a broadcast on VLAN 10. That's received by CX1. CX1 will forward that broadcast traffic to devices that it has as part of the mapping between VLAN 10 and VNI 10,010. CX1 has a route type 3 from CX2, and using the route targets for the VNI 10,010, that's been imported, which means essentially that CX1 will forward this bum traffic over to CX2. So the ARP request, the broadcast traffic that goes from server 1 to CX1, it gets forwarded from VLAN 10 onto VNI 10,010, goes over to CX2, which forwards that bum traffic onto the other ports that are configured within that broadcast domain. So VLAN 10, it's got the mapping, of course, between VLAN 10 and VNI 10,010. It forwards it out of this port, 1/1/3. It hits router 1, and that ARP request for 10.99.10.1, that is for router 1. So router 1 responds, it responds back to server 1 saying, oh, yep, I've got that IP address and here is my MAC address. That will go back to CX2, it will be sent back over to CX1 and forwarded on to server 1. Now CX2 and CX1, when they're doing their forwarding across the EVPN network, they're looking for MAC address, which this one for server 1, because that was the source MAC that it was broadcast from, that's what they're responding to. Well, actually, CX2 will be doing forwarding based upon its route type 2 for this MAC address. You know, it's not the IP address at all. That's one of the things I want to emphasize. Okay, so CX2 remotely learned MAC address of ending 1BDE94. That will be known via 172.16.0.1, and that will be forwarded from CX1 out of the port that it is locally learnt on, which is its 1/1/10. So the ARP response will go back to server 1. It will populate its ARP cache. So when server 1 has traffic, which is into subnet, so we're doing that ping from server 1 to server 2, which is in a different subnet, server 1 will send that to the IP address of 10.99.20.16, but it will send it with the MAC address of its default gateway, which is over here on router 1. These devices, so CX1 and CX2, will do their forwarding to router 1 based upon the MAC address of router 1. So we're using the reachability. CX1 has learned about router 1's MAC address via the route type 2, which is sent by CX2. So the ping will go from server 1 to CX1. It'll be sent across on VNI 10,010 to CX2. CX2 knows about router 1's MAC address because it is locally learned across VLAN 10. That hits router 1. Router 1 will route between 10.99.10 and 10.99.20. You know, router 1, I'm not including every step here. You know, I'm just riffing on this to some degree. So router 1 will have, you know, let's say router 1's got the ARP cache for server 2. It will forward the traffic towards 10.99.20.16 with the MAC address of server 2. So that will be sent across VLAN 20 to CX2. CX2 is going to do its forwarding based upon the route type 2 that CX1 has sent it across on VNI 10,020. CX1 will receive that and send it on the locally learnt MAC address for server 2. Okay, well that was a lot to explain. So what we're going to do is we're going to step through using Wireshark to show you the packets flowing across the network. And what I've done is I have mirrored on CX2, I've mirrored this port here, 1/1/2. So the port that faces CX1. We'll be able to see the traffic coming and going across the VXLAN network. So let's step through the process then. Okay, and on server 1, what I'm going to do is I'm going to clear the ARP cache for the default gateway, and then we're going to do that ping to 10.99.20.16, which will fire off the traffic. And we can see over here, so this is the ping here. Right, if I stop that then, I can see this traffic. So this is coming off of CX2. So the ping's going to come from server 1 across the VLAN across to CX2. Let me make this bigger and I'll just bring it up when I need it rather than keeping it on screen the whole time. Yeah, that looks good. Okay, so here we have the ping. This is coming from server 1. That's my ARP, who has coming from, yes, resolved it there. The source is a Raspberry Pi, which indeed it is. And it is saying, who has 10.99, 10.1, tel.16. Okay, so that's our ARP request that is being sent from here across, and I'm picking it up here. So you can actually see it does go across the VXLAN network. There's the VXLAN for it. And it is broadcast. So the inner packet is from our Raspberry Pi, and it's been broadcast across that network between, there's the loopbacks for CX1 and CX2. So that ARP request is going all the way from server 1 across CX1 to CX2 and down to router 1. Remember, from the point of view of CX1 and CX2, it's being handled as BUM traffic is broadcast. So it's being forwarded on that broadcast domain. So that hits router 1, which responds back to, and you see the destination there. The destination of that on the inner part of the packet is going from router 1 back to this destination MAC address. So this is not BUM traffic now, okay? And you can see the requests going between them for, I've put in the different pings that are going off, right? So we'll move on to that in a moment. Okay, so what we have here is you have the BUM traffic coming in here. This is the ARP broadcast traffic, and then the response, and this is the point I really wanted to emphasize, that when we are on, so if we go CX1, when we are on this device, the bum traffic. Now, what forwarding are we using here? Of course, we are using for the mapping between VLAN 10, the traffic comes in on VLAN 10, and it's mapped to VNI 10,010, it's bum traffic, and we forward that on to CX2 because we've got that route type 3. So this is the relevant entry for the traffic, why that broadcast for the ARP request, why that traverses this VNI over to CX2 is because of that route type 3 that was sent by CX2. And then when you're over on CX2, can I split this? So if I'm over on CX2, and this is, I mean, I am labouring this quite a lot. I know this is a long session, but this is the kind of thing, if I was teaching this in a room, this is how I do it. So what table is being used by CX2? So we know the entry that we've used to forward this on was coming from a remotely learnt IMED, which meant that we forwarded it from CX1 to CX2. What's CX2 using to forward this on? It's going from VNI 10,010. It's using VLAN 10 to forward that. It's just flooding that out of the ports that are associated with that broadcast domain. So it's configured in with a trunk for VLAN 10. That's what's configured. So we forward that on to router 1. It hits router 1 at this point. Now, router 1. Let's log into router 1. Here's router 1. What do we see for router 1? Of course, we've shown you the routing. For router 1, it's just got those directly connected interfaces. It receives the information from server 1. If we look at its MAC table, you'll see the MAC address. That is the MAC address of server 1. Now, that was learned. You can see that there. So it's DE94. Okay, so that was learned because the ARP request came from that source MAC address, and you saw that in the Wireshark. So when it responds, router 1 sends the response back to, here's the ARP response, it sends it directly. So the ARP request was broadcast out, and we were using the route type 3 entries on our VTEPs to get to router 1, but when router 1 responds, we respond directly. So it's a known unicast ARP reply. It's that MAC address. So of course that MAC address, then if we track that back through, we are actually forwarding using a different entry. So on CX2 we're actually using that entry for the MAC address. Now, what was the MAC address? It is the 1BD94. It's going to be in 10. It's going to be 1BD94. That's what we're using. So we've learned that from CX1. You can jump through, of course, I'll skip the EVPN table. We'll just go for the MAC address table. CX2 is doing its forwarding based upon that remotely learnt MAC address, the D94, which is known via 172.16.0.1. We've learnt that via EVPN, so we are sending that back. You should be able to see it. Yeah, okay, so here we have, this is from the point of view of CX2. That's what, remember, that's where I've mirrored the port. This is coming from CX2. You can see that we are actually, the inner packet is from router 1, is going to the Raspberry Pi. It is using VNI 10,010, and we've got the source, which is CX1. CX2, and it's going to CX1. We're using VXLAN. Okay, so we are sending that response, and you'll see these. You've got these different ping requests and replies going backwards and forwards across that link. So at the different stages, we're using the different tables. I think that's really important when you're doing some deep troubleshooting. It's that old advice of, like, think like a router, think like a VTEP. Like, what process is this device actually applying to this packet? And in the case of CX2, what it's doing is it's using that route type 2 that's learned from CX1 to forward this on, and you can see that with the VXLAN. Then if we were over on CX1, we will be doing, for the MAC address, that was learnt, the destination for this, so essentially this MAC address here, that was learnt because server 1 did the ARP request. It's just been dynamically locally learnt, and there it is, okay, across port 1/1/10. So in this case, we're doing, well, in both cases actually, CX1 and CX2, we're doing switching. On CX2 for the traffic to, so let's say, so CX2, the traffic coming back, that is switched from 802.1q, and on CX1 it's switched from a VNI to a VLAN, which will then hit server 1. And server 1, once it's done its ARP request, it will send the pings, and you can see the pings there that are being sent across. Okay, so there's a lot there about that, a lot to digest. But the key part, I think the key part is really think like a router. Now, what I wanted to do then for this file, let's save that off. Well, not save it, I've just wiped it actually. So what we're going to do is I want to show you some of these updates then that you will see, the updates coming from at the control plane. Where am I? Right, so CX2, what I'm going to do is I'll show you the BGP updates that you see on CX2. Let's have a dive into those. Now, if I'm on, how should we do this? Let's go over, I'm already on router 1. So if I shut my interface on router 1, let's go over to Wireshark. Come on, bring up Wireshark. I've colorized some of these updates, so that's why you get some funky colors on here. And what I'm going to do, I'm going to no shut the router interface. What will have happened is that we would have wiped the table, so the MAC address for the default gateway will be removed at this point because I've shut that interface. I'm going to open it up, and so when CX2 receives some traffic from router 1, it will record it in its tables and it will send the BGP updates for EVPN. So let's record those. Have I got Wireshark running? Yeah, I've got it running. Let's no shut. Okay, no shut. Okay, I think let's stop. I think that will be enough. So we've got some BGP updates here coming from CX2. There's my update. Let's zoom into that. Okay, here's the update that CX2 has originated. So it's BGP update message. We've got the path attributes here, which I won't go too deep into. Incomplete. AS path is empty because it's locally generated. You've got the extended communities. This is, you've got the route targets. That's why it's really important to send community both on your BGP configuration for EVPN. You've got the route targets there. We've got the encapsulation type. And here's the good stuff. This is the multi-protocol network layer reachability information, the NLRI. You can see the address families at L2 VPN. We've got the EVPN. Next top, of course, this is where it's locally generated. It's CX2, so it's that 172.16.02. What happens when we open that? Oh, it's just the IP address. Okay. Now we can see this is a MAC advertisement route. So it's a route type 2. There is our 2. We got route distinguisher, which is the auto-generated. You can see this is the update within. We've opened that interface, which is a trunk that's got VLAN 10 and 20. This is for VLAN 20 from router 1. Because I know that because behind the colon you've got the following the colon you've got this 20, and you can see here that's the MAC address there. So this is the important, that's the reachability information. That's the MAC address. That is the MAC address of router 1, which we are advertising for VLAN 20 in this case. Now you do get this with Wireshark. It gives you a warning because there's no IP address included. Okay, thanks very much. Apparently you can't turn that off, but you know, fine. You don't need to have an IP address as we proved here if it's just an L2 VNI and our VTEPs are just doing layer 2. You can see right down the bottom there you've got the VNI for that, which is 10,020. So if I go over to do I have an update for the other? Right, I should have 2 then, because you know router 1 has got MAC addresses in both. So let's close some of this up and just look at the thing that we really want, which is, I can't scroll down anymore. Maybe I can just bring it up a bit more there. That's not what I wanted. No, not that. Okay, come on. There we go. Maybe I'll just bring this down to focus on what I am interested in, which is the reachability info, which we've got there. If we get a little bit bigger. So, route type 2, Route distinguisher again, auto-generated VLAN 10. So this is the other one because router 1 is both in VLAN 10 and 20, as I've mentioned. There's the MAC address, and it's in VNI 10,010. So that is being sent across. As I open the port here, we heard from router 1, and CX2 sent a route type 2. So you can see what it actually does. It sends 2 updates, so 2 separate updates we've got there. And just if you're curious, so those will be imported by CX1, and it will update its L2 VPN, EVPN, BGP table for our reachability. And the other thing then, which you may be curious about, is let me start that up. Yeah, continue without saving. And we will shut it again. So when we shut, we get the withdrawal. Okay, so this is how we remove the information from our tables. If I check, let's go, yeah, I've just shut that down. So if I go, let's go CX1 then, we'll just jump straight to the MAC address table. So now we don't see that because the port router 1 is shut down. We've had the withdrawal, which removes it from the reachability on CX1 across here. Now that's because CX2 here has sent this BGP withdrawal, which is this message, and it sends 1 update for that. So let's focus on what we are interested in, which is the withdrawal routes. Okay, so you have the withdrawal. This is just like standard BGP with some extras for EVPN. So we've got the withdrawn routes, and those are both withdrawn routes are combined in a single update. Then I'll stop that going. So they're in a single update. You've got your route type 2, but it's for a withdrawal. And you can see there you've got the one for the essentially this MAC address, so router 1's MAC address in VLAN 20 and in VLAN 10 combined in a single update by the looks of things here. Okay, so this withdrawal message, that is when CX2 sees that the port to router 1 is shut, it flushes its MAC table. Let's go over to CX2 rather than just talking about it. Show you what's going on. So the port's down, show interface 1/1, so it's physically down. You can see it's down like that. So it's going to flush the MAC address table. These are the remotely learned, of course, but we don't have any dynamically learned on port 1/1/3 because that's been shut down. That means that in its EVPN table, so it doesn't have any locally learned in its EVPN table, and it will send that withdrawal to withdraw it from the BGP EVPN table. So these are the locally learned ones. You can see there's no route type 2s in there anymore. Those were flushed. It sends the withdrawal message over to CX1, then CX1 will flush its BGP table on receipt of that. Show BGP into EVPN. You can see coming from, or maybe let's do a more specific command because I keep doing this. What would I do if I say display neighbor? No. I want to drill down. So can I just do let's see if we can do that. I don't normally do, right, this looks good. What am I receiving? Okay, great. So there you can see I've just done VTEP and I put in the VTEP IP address, and you can see that now we're not receiving any route type 2s from CX2. Okay, so if we go over here, no, shut. So if I do, was I running? No, I wasn't running, but if I've known shut that, we should see, yeah, there we go. Router 1, it's being learned. So there you can see the update, right, which allows us to do that end to end. I think the last say should go to server 1. Let's do, I will do an SSH over, not just a ping. Let's go step it up a level. Need the IP address for that. Okay, so server 1 doing an SSH all the way over to server 2 using the connectivity across the VXLAN network for this. Fantastic stuff. I know that was quite messy. The idea of these is to be a bit more quick and dirty and just kind of a bit more ad hoc with the things that I'm going into rather than the really prescriptive kind of explainer series. I hope you found that useful. What I was thinking for the next one, what I was going to do is to take this on the next layer and put these in different VRFs. So rather than just inter-subnet routing, let's do some inter-VRF routing over on router 1. Okay, so that will be the subject of video 3. Maybe it'll be a bit tidier than this one as I work out the format for this, but I hope you found this useful, and that just leaves me to say my name is Joe Neville. Thanks for watching, and goodbye.